So the key to this whole thing, or one of the keys to it, is the idea of a decentralized identifier. So this is an identity that belongs to you, and you can have more than one, but it's an identifier. It's like an ID, so like your employee ID or whatever. It's an ID. But the difference with this one is instead of your employer giving it to you or your university giving you a university student ID or whatever, this is an identifier you generate for yourself, and you own it and you control it. And when it's created, at least when you use a decentralized identifier, or a DID as they're called, the DID is written to the blockchain. So that means it's recorded forever, can't be changed on the blockchain, and it is there. And that means there's now a representation of you on the blockchain. Again, it has no details about you. All it is an identifier. It's a string of crazy characters, not really meaningful to anyone when they see it. With a decentralized identifier, with a DID, you have keys. There's two different types of keys. One is called a public key, one is called a private key. And a good analogy for them, I think, is probably sometimes when you have a car, you'll be given what's called a valet key. So you'll have your regular key, which gives you full access to the car, the trunk, the glove box, everything like that. But then you can also have a valet key, which is a key that you can give to, you take it to the garage, or you take it to a hotel that has valet service, or whatever. You give them, it gives them the access to open the door and start the car, but it doesn't give them access to the trunk, doesn't give them access to the glove box. So it's sort of, they have restricted access with that key. So public-private keys are sort of like that. It's not a perfect analogy, but it's close enough. Where the private key would be like your key that gives you full access to the whole car, and the public key would be like the valet key. It gives you just partial access to things. You never share your private key. You never share your master key to the car. Sort of, we'll go with that analogy for now. So anyway, so what happens is when the issuer, the university or the government agency or whatever it is, issues the credential, they take their private key and they sign the credential. So it's just, like you could sign with your pen and ink or whatever. You can sign it digitally using these keys, which again does cryptographic math, produces a crazy hash value, which is a big series of numbers and letters. And again, that is reproducible. It's going to be consistent. You sign the credential with that private key, that master key, and then the credentials can go out to the holder, to the person who's using it. And then when they want to present it, whoever's verifying it will take that credential, and they know who the issuer was. They know which university gave it to you. They can go to the blockchain, get the public key from the decentralized identifier that's on the blockchain, and they can use that public key, and that public key allows them to verify the credential. And they'll say, yes, this credential was signed by that university. We can prove it, again, using cryptographic algorithms. So there's a lot of cryptography here, as you're probably understanding. But that's sort of how the decentralized identifier and the VC come into play together, is that signing, which is the proof of authenticity. It's the rubber stamp, or from the olden days, the wax seal on the king's letter or whatever. That helps prove that is who did it.